Hi, CS 152 students. This is Professor Pierce. And this is a video. I hope it's going to be a short video to make up for the fact that I forgot to record the last lecture. The last lecture, Google here, show you how to navigate there. So CS 152, you click on Lectures, Scala Programming Notes, Language Processing in Scala. So this was the material that I covered. It was about grammars and parsing and Scala's parser combinators. So rather than just read through that for you, I put at the bottom here, you might have to reload this page to get this link, a link to basically the same examples that I did, but I think it's a little more direct, maybe a little simpler to follow. So here is SOP. This is a little toy language I invented. SOP stands for sums of products. And so it's a language for computing sums of products. Here I actually have it running here. So I can just type in numbers by themselves. They can be signed numbers, negative numbers. You'll see two things being printed out here, like a tree and a number. So we're just going to focus on our value. We're going to focus on the value. The tree is the output of the parser. I should have turned that off. Here's 2 plus 3, 2 plus 3 times 5. And notice the value is 17, so the multiplication was done before the addition. If we had done 2 plus 3 times 5, 25 is the value, so now the addition is done first. So multiplication has precedence over addition unless parentheses are used to force the addition to happen first. Okay, so I'm going to quit out of this for now. Let's build this. I'm going to build it from scratch using the notes that I have. So I'm going to go up here and I'm going to create a new Scala project, and I'll call this Scala project tutorial. So let's see, where was I? Oh yeah, so tutorial here. I'm going to add a new package here. I'll call this package SOP1. We're going to do two versions of this language. Let's see, so SOP1, I'm going to create in here a new Scala object called console. I usually spell the name of a singleton object with a lowercase letter. And then I'm going to go back to the website, click on this link, and copy all of this into here. Okay. So this is the console the user interface, console user interface. It's got in here some parsers. I'm getting an error message there because I haven't defined the parsers yet. Here's the read, execute, print loop. And basically it's a perpetual loop that prints a prompt. It reads in a command typed in by the user. If the command is quit, we get out of the loop. Otherwise, we take it as a command and we execute it and print out the result. Up here, we execute it. We're going to take the command. We're going to parse it with our expression parser. More on that later. That produces a result. There are two kinds of results, either a failure indicating a syntax error, so here we'll throw an exception. Otherwise, the other case is that we're going to extract from the result some kind of an expression. We will print the expression, then we'll execute the expression, and we'll return the value of executing it as a string. So that's, the basic rundown of that. The expressions. Okay, so there are two versions, as I said, SOP1 and SOP2. So this is a hierarchy of expression classes and subclasses. Here's a UML diagram. At the top of my hierarchy is this expression trait. They don't really have that in UML, so I'm just using a stereotyped abstract class for that. And then I've got three subclasses, sum, product, and number. Remember, this arrow here means that sum is a subclass of expression. Now, let's just focus on, let's look at number first. So number is an expression, and number encapsulates inside of it a Scala double. So it's just like a wrapper class, a way of smuggling Scala doubles into this SOP language. Here is a sum. Now, these little arrows here I read as has a arrow. So a sum has one operand of type expression, and then the sum has 0 or more operands of type expression. So basically what I'm saying is that it's an operand possibly followed by more operands that are to be added together. Let me say that again. It's an expression possibly followed by more expressions, the values of which need to be added together. Okay, here is the code, and I'm just going to move this into, I'll say, new Scala trait expression. Declaration. Okay, so here it is in code then. So an expression is just something that knows how to execute itself. And here's my sum. These are all of the expression classes are going to be case classes. Remember, when you declare something a case class, it automatically generates a companion object with apply and unapply methods. So the apply method creates a sum. The unapply method extracts the components of the sum. So here's operand 1, which is an expression. That'll be the value of that should be added to. And then here are operands. This is a list of expressions. So additional expressions. And the whole thing extends expression. And here's how I implement execute. I'm going to execute operand 1. And then here I use the map reduce in Scala. So I'm going to take each of the operands. Remember, they're expressions, and so they should know how to execute themselves. So mapping the execute transformer down a list of expressions should produce a list of doubles, Scala doubles. Remember, up here, the values are Scala doubles. And then we're going to use reduce to add all of those things together. And here it shouldn't matter if, it probably does matter. I probably should have checked to make sure that operands wasn't the empty list here. Although I don't think I got an error message from it. This should, I'll fix that in the code. And product is the same thing. Executing a number just returns its encapsulated value. So here is a grammar for SOP1. So grammars are the way that we specify the syntax of a programming language. The grammar is a set of rules. Here's a typical rule. The left-hand side of the rule is the name of a part of speech, I guess, or a type of expression. And then the right-hand side, this consists of, and then the right-hand side shows the format of that expression, the pattern that those expressions have. So here I'm just saying, well, an expression is a sum. What is a sum? So this is the rule for sums. A sum is a product. This means followed by, and then in parentheses here I have a plus sign, a literal plus sign, followed by another product. And then this means repeat 0 or more times. So this is how you interpret that. A sum is a list of one or more products separated by plus signs. So that's what this is, one or more. Here's the first product. And then here we have additional products with plus signs in front of them. A product is a list of terms, one or more terms separated by multiply signs. A term is a number or, that means or, an expression inside of parentheses. So a left paren followed by an expression followed by a literal right paren. And then number, so here you'll remember from a while ago, triple quotes means this is a raw string in Scala and other languages. And then .r means take this string and turn it into a regular expression. So we can use regular expressions as rules in grammars. So here, this is an optional plus or minus sign. This is the pattern for a number, followed by one or more digits, followed by question mark means optional, optionally followed by a decimal point, followed by a string of one or more digits. And then a parser, just a little review. A parser is a function that takes two inputs, a string and a grammar, and it takes this string, uses the grammar to convert that string into an expression, or it returns like a failure, an error of some sort if the string contains syntax errors. So this string is what the user is typing in our read, execute, print loop in our console. And then the parser is turning it into an expression, and by expression, I mean a sum or a number or a product. Okay, so now let's click on this. Here are the Scala parsers, parsers 1, and I'm going to go here. I'll just paste in my definitions. Now, you may have noticed we've been getting errors all along. We're getting errors here too. And the reason why is because we haven't loaded in the parser combinator library. So I'm going to right mouse click on tutorial. I'll go to properties, Java build path. Okay, here are the libraries that I have in there. Add external jars. And then I'm going to go find one of my Scala parsers here. This 212 looks good. Okay, so here, apply and close. All of, let's see, I still am getting errors here though. Maybe I have to save some stuff. Yeah. So here in our library, we have, let's see, I would have referenced libraries. Oh yeah, Scala libraries. So up here in the, let's see what libraries we're using here. So this is the Scala language library 2.12.3, and the combinator is 2.12 2.12-1. The important thing, I think, is 2.12, 2.12, that these more or less match up. Usually, if you're getting errors at this point, that's why. All right, so let's look at these parsers now. So here is the grammar inserted as a comment. Well, first of all, I need to have this include statement here. That's using that from the parser library. Regex parsers are from that library I just loaded. These are parsers that can include regular expressions, which I need. Okay, and this thing here, let me go back here for a second. Yeah, let's just look at this part right here. Okay, this is shorthand, so parser of expression is shorthand for something like this. This is sum as a function which takes a string as an input and returns like an optional expression as an output. That's our expression class there. So a parser will transform a string. The sum parser transforms the string either into an expression or it'll fail. It'll return none. Some sort of a failure object if the string contains any syntax errors. Okay, so expression is the top level parser. I'm defining, this is actually a function I'm defining, and it's just the same as the sum. Here is the sum, we were just looking at it. Now, the definition has two parts. There's this part, which I call the raw parser, okay? And notice how similar it looks to the rule up here for sum. Product followed by, so we have a product followed by, now we don't have star, instead star is replaced by REP, which stands for repeat. So product followed by a repetition of the plus sign followed by product. And this funny little arrowhead here means check to make sure the plus sign is there, but don't include it in the final output. Okay, so this part, so now here's the way to think about this. It's kind of mind-blowing. Product is a parser that I'm going to define down here. So product is a simpler parser, and followed by and rep are combinators. So rep is a combinator that takes this parser and turns it into a parser that checks for a sequence of products. Okay, this guy here is infix combinator. It takes this product parser and combines it with this product parser. So it's saying basically I want a product followed by a repetition of plus signs followed by products. Okay, so that'll generate a tree for us. And then I'm going to, I read this as transform. Take that tree and transform it. So the tree is not yet an expression. And so here are the possibilities. Let's say that the output of the product parser here is P. The product parser is just right down here. And let's say that, so rep, the output is going to be a list of products. Okay, and one possibility is that it's the empty list. In this case, I just return P. So a sum degenerates into a product. A sum that only consists of one product just turns into a product. The other possibility is that rep here produces a list of products, which I'm calling prods here. And now here I call the sum constructor, and if we go back and take a quick look at the sum constructor, what does it want? It wants operand 1, which is an expression, and operands, which is a list of expression, as inputs. Okay. Right, so product is the same, except we have terms there instead. here a term is a number or is another combinator. And then here we have a left paren followed by an expression followed by a right paren. And the arrowheads indicate, hey, drop the left paren, drop the right paren. And then here's our regular expression for number down here. So coming back to the console, we can run it. So here's 34. The value of 34 is 34, duh. And then here's the tree. It's a number with 34 inside of it. Now let's do 2 plus 3. Its value is 5. And see, it's a sum that consists of the operand 1, which is a number, and then operands, which is a list consisting of just one number, 3. All right, let's do 2 plus 3 plus 4. So it's a sum. Operand 1 is the number 2. And then operands is a list consisting of two numbers, number 3 and number 4. And so that's the raw tree that's being generated. Come here. So here, 2 plus 3 plus 4. So I've drawn this little, this is actually a UML object diagram showing a sum object. And it has operand 1 is the number 2. And then the operands is a list of expressions consisting of the number 3 and the number 4. Here's a little more complicated. This is 2 plus 3 times 4. So this is a sum. Operand 1 is 2. Operands is a list of expression, but only contains one thing in it, which is a product. That product has its operand 1, which is 3, and its operands is a list of expression containing one thing in it, the value 4. Okay? All right, let's take a breather for a moment before we move on to SOP2. Right. So SOP2, just a different approach just to get you used to seeing what's available out here. So whereas SOP1, a sum is a list of one or more expressions, in SOP2, a sum is one or two expressions. So here a sum is an expression, operand 1 is an expression, and operand 2 is an expression, but I've got this 0 or 1. So maybe it exists, maybe it doesn't exist. Same is true for product over here. So let's grab expression hierarchy for this. Come over here, I'm going to add a new package. I'll call it SOP2. And here I'll add a new trait, expression. I'll just paste in all of that stuff that I had. So here the issue was, how do I express that a sum is 0 or 1 operand? I'm sorry, operand 2 is 0 or 1. So here's operand 1, which is an expression, same as it was before. And now instead of operands, I have operand 2, which is a maybe expression. So I'm going to use that Scala's option for that. So it's an optional expression. It could be none or it could be some. And then here's execute. So if operand 2 matches none, then just execute operand 1. Forget about it. On the other hand, operand 2 might match some exp. So this exp is an expression. And so then operand 1.execute plus exp.execute. So here we're relying on recursion, whereas the SOP1 was more iteration. So we used map to iterate over a list, but here this operand 2 could be any expression, or exp can be any expression at all. Okay, let's look at the grammar now. So this is a different grammar for SOP2. An expression is a sum. Okay, a sum is a product followed by, and then here I have a plus sign followed by an expression. So far it looks the same, but here instead of star I have question mark. Question mark means optional. Okay, so the plus sign in the following expression are optional. And then same with product except with the term. So here I would have had product star here. Sum is a list of products, but I'm going back to any expression can go in here, so we can use recursion. Here are the parsers for this. Parsers 2. Whoops, wrong package. I didn't need to call it parsers 2. I could have just called it parsers again. Oh well. Okay, and then I'm just going to put a copy of console in here. Here's console. The only thing I'm going to change, I think, is parsers 1 gets changed to parsers 2. Picking up lots of errors there for some reason, but let's see. I've got parsers 2, I've got console. Oh. Oh, console is defined twice. It was in the SOP1 package. All right. Hi, I'm back again. So I think what I have to do is just recreate this in here. Let's see, I think it was a Scala object console. I think it didn't like the fact that I did like a copy. I wasn't sure that would work. It didn't. I'm going to change this to parsers 2. Okay, so let's look at parsers 2. So parsers 2 also extends regex parsers. And then let's focus on the rule for sum. So sum combines the product parser defined below, followed by, and now we don't have question mark here. Instead, optional is OPT in combinator language. So OPT is a combinator for generating a parser from a parser that's, starts with a parser and then it recognizes whatever that parser recognizes or the empty string. So plus sign followed by an expression. Okay, now there are two possible outputs for this parser here, raw tree outputs. First is P, I forgot to mention, OPT doesn't return a list like REP does. It returns an optional value. So here, see how nicely OPT dovetails with Scala's optional value. So one possibility is the output of the product parser, we call that P, and the output of the option parser is none. And then we just return P then. The other possibility is the output of the product parser is P, and the output of the optional parser is sum with an expression inside of it. And so here we call our sum constructor P and sum expression. And remember, let's take a quick look at that guy. Yeah, remember operand 1 is an expression and operand 2 is an optional expression. Okay, so let's run this guy. Okay, so 2 plus 3 is 5. Yes, thank you. And notice the parse tree, it's sum. And here's operand 1. It's the number 2.0. And then operand 2 is a sum with the number 3.0 inside of it. So this is also a sum. Operand 1 is the number 2. And then operand 2 is a sum. And inside of it, it's got a product. Its operand 1 is a number, and its operand 2 is a sum containing the number 4. The value is 14. Here is the tree generated. This is 2 plus 3 times 4. I think that's the one we just did. So it's a sum. Operand 1 is the number 2. Operand 2 is a sum object. Remember, sum is S-O-M-E. Consisting, and inside of it is a product. Its operand 1 is 3, and operand 2 is a sum containing the number 4. Okay, I think that is all for now, and I will see you here from everybody on Tuesday.